Okay, so first we looked at gas tungsten arc welding, a non-consumable process of polarity. Now let's look at how the consumable processes work out, but these get pretty goofy. So we're looking at consumable processes. So we're talking about specifically stick welding, what a lot of you would refer to as MIG. I would call this shielded metal arc welding. And I would call this a wire feed process. So these processes specifically. Now in the wire feed, there's a second video that'll just talk about the nuances of the modes of transfer. And I'll send you off there for that. But the basis will be the same for both of these, just so you know. Okay, let's get into it. First, we have two things that we need to accomplish. First, we need heat. And second, we need to transfer whatever our welding electrode is. So specifically, I'll draw a stick example here. We need to transfer this electrode into the puddle as it melts down. So kind of interesting how we do this. So take good notes. First off, the first step that we do is we pass electrons up into the plate. Up into the electrode. So that makes this negatively charged and this positively charged. We call this DC, electrode positive. We can also call this DC, reverse polarity. Reverse polarity. It's like you're shifting your car in reverse. This part's a little goofy. First, all the heat you'll notice is right here. Keep in mind, electron flows from negative to positive. Where they land, this is where all the heat is. So all the heat is there in the electrode. What we're doing here is we're getting this electrode really hot. Electrons are coming up. We got about 30% of the heat here, and we got about 70% of the heat here. We're making that electrode nice and hot. The tip of this electrode then becomes a ball, and it desires to separate itself from the rest of the electrode. Magnetic forces are now pulling this electrode into the puddle. Magnetism is pulling this tip of this electrode into this puddle. As those forces bear down on this molten ball on the tip, this electrode starts to neck until it gets small enough that the magnetic force is actually strong enough to pinch off that residual little neck, and away you go. This pinching is called the pinch effect. Proper noun, so we use effect. This little ball gets hot. The force is the magnetism, pulls it down, and eventually this force becomes so great that it counteracts its tension with the rest of the electrode, and the ball falls into the puddle. When this ball comes across into the puddle, it brings all that heat with it. 90+% efficient. So we already had 30% of the heat here. 90+% of 70 is going to put us at another 63. So now we have 93% of the overall heat generated on our plates. So whenever we're stick welding and we want really good penetration, we want the highest heat we can use, we're going to use DC, electrode positive. Or DC, reverse polarity. It's the same thing. It's just saying it in another way. That is where we get the greatest heat in the basic drill. So let's say that we don't want much heat. Let's say we're welding something really thin. And we don't want much heat. We don't want all the bad side effects of too much heat. Well, the least amount of heat, this is the greatest, and that is heat in the base material. The least amount of heat is going to be DC electrode negative, which we can also call DC straight polarity, like a little line, straight. And obviously you'll see with electrons flying into the plate, we're going to end up with 70% of that heat in our plate and 30% of that heat up here. Now as electrons exit this ball doesn't get formed quite so large, so there isn't such a great heat transfer, and we're not going to bring across much of that heat. I actually don't know the exact amount. They say this is a very cool process between 70 and 80%, so I would guess we only get about a third of that heat, 30%. This is going to be the coolest process. This is good when you're welding overhead, you're welding on thin sheet metal, something like that. DC electrode negative has the least heat in our base material. That's because we're not heating up that ball. The impact of that mass is not transferring the heat for us. Little teeny bits are going across and they cool. There's a little bit of a cooling effect as they cross that envelope. Not as much heat by any stretch of the imagination. Sometimes when you're welding with the DC process, actually every time, let's say you're doing a couple of plates and you're doing DC reverse polarity. Remember that's the same as electrode positive. You have two plates and you weld across. By the time you start reaching this end, you have magnetically charged these plates, and rather than attract this little ball into the puddle like we discussed before, you start to repel that ball. This ball goes flying out of the puddle over and over again. You actually repel it off, so that at the end of the plate, you end up with like a little divot like that, a little hole. You don't have as much, or your weld is just a little flatter. This particular effect is called arc blow. It's because you've charged your plates, and as you reach the end, you end up with two of the same poles, and they end up repelling that electron off. So instead of that little ball of material coming across the plate, it gets blown off and it starts making more spatter and some of the debris. That's called arc blow. One way that we can combat that, we can use AC. That flipping of the poles back and forth that AC causes will diminish a lot of those magnetic charging properties. Keep in mind, we'll still have the magnetic properties taking that ball across, but we're not going to have those charging properties, which makes it into a magnet. So AC is the way that we get out of arc blow. And AC really has the average penetration. So it has the average heat input into the plates. So you're welding something hot, you want really good penetration, you're doing a nice root pass, DC electrode positive. You're doing a nice long weld, you have issues, you're starting to develop magnetic properties, you're starting to dig out your weld towards the end. AC will help out a lot with that. Plus a lot of welders come AC. Finally, you're doing something overhead, you're doing something thin on sheet metal, you don't have another machine, you don't have a thin wire feed machine, something like that to get through this, DC electrode negative. The principles roughly hold the same for wire feed. There are some nuanced differences, so be sure when you look through the wire feed video that you look for those as well. There are some minor differences. I hope that helps with polarity. Feel free to email me any questions you may have.